Hello friends, welcome to EC Academy.
In this lecture, let us understand wavelets in image processing. Fourier transform is generally used for image processing since 1950s. More recently, wavelet transforms are used for image processing. Wavelet transform has made the images even easier to compress, transmit and analyze. So this is the advantage of wavelet transform compared to Fourier transform. So it has made the images even easier to compress, transmit and analyze. In Fourier transform, the basic functions are sinusoids, and in wavelet transform, small waves that are known as wavelets of varying frequency and limited duration. So wavelet transform uses small waves which are known as wavelets of varying frequency and limited duration. In the year 1987, the wavelets were first shown as the powerful new approach for signal processing and analysis, which is known as multi-resolution theory. So in the year 1987, wavelets were shown as powerful new approach for signal processing and analysis for multi-resolution theory. The multi-resolution theory incorporates subband coding, quadrature mirror filtering and pyramid image processing. So these are the transforms that are used in multi-resolution theory. As the name implies, multi-resolution theory is used for representation and analysis of signal at more than one resolution. So multi-resolution, which means multiple resolution, as the name implies, it is used to represent and analysis of signal at more than one resolution. Now let us see the background of wavelets. Whenever we look at the image, generally we see connected regions of similar texture and gray levels that are combined to form an object. So in an image, we have some similar textures as well as gray levels that are combined to form an object. If the objects are very small in size or low in contrast, we normally examine them at high resolution. If both small and large objects or low and high contrast objects are present, then it can be advantageous to study them at several resolutions. This is the fundamental motivation for multi-resolution processing. So we can say in an image, if small and large objects are present or low and high contrast objects are present, then we can go with multi-resolution processing. Now let us understand image pyramids. An image pyramid is representation of image at more than one resolution. So we can say a powerful and simple structure for representing image at more than one resolution is image pyramid. The image pyramid is a collection of decreasing representation of images that are arranged in the shape of a pyramid. It was originally used for image compression applications. This figure shows a pyramid of image structure where the base of the pyramid consists of high resolution representation of an image that are being processed, and the apex of the pyramid contains a low resolution approximation of an image. So in this image pyramid, as we move up, both size as well as resolution of an image will decrease. The base level is having the size of 2 to the power of j into 2 to the power of j, or we can say n cross n. Here j will be equal to log to the base to n. The intermediate levels is of the size small j, that will be equal to 2 to the power of small j into 2 to the power of small j, where small j will range between 0 to capital J. The fully populated pyramid are composed of j plus 1 resolution level from 2 to the power of j into 2 to the power of j to 2 to the power of 0 into 2 to the power of 0. So as you can see, 2 to the power of 0 into 2 to the power of 0 is 1 cross 1. 2 to the power of 1 into 2 to the power of 1 is 2 cross 2. 2 to the power of 2 into 2 to the power of 2 is 4 cross 4, and so on. Most pyramid are truncated to p plus 1 level. So most pyramid consist of p plus 1 levels, where small j will be equal to j minus p and so on up to j, and here p will be between 1 to capital J. The total number of elements in p plus 1 level pyramid for p greater than 0 will be represented by this formula, which is given as n square into 1 plus 1 by 4 to the power of 1 plus 1 by 4 to the power of 2 plus and so on up to 1 by 4 to the power of p, that will be less than or equal to 4 by 3 into n square. This is one of the example of image pyramid where at the base level we are having a high resolution image, and at the apex level or the top level we are having a low resolution image. These images are arranged in the form of a pyramid for the analysis of images. This is the block diagram for constructing image pyramids. The level j-1 approximation output is used to create approximation pyramid which contains one or more approximation of original image. The level j prediction residual output is used to build prediction residual pyramid. These pyramid consist of low resolution approximation of original image and information for the construction of higher resolution approximation at other level. The information at level j is the difference between the level j input image as well as the prediction that is obtained from level j-1 approximation, as you can see in this figure. This difference can be coded and therefore stored, and also it can be transmitted more efficiently. The approximation and prediction residual pyramids are computed by iterative functions as shown in this figure. A p plus 1 level pyramid is built by executing the operation in the block diagram p times. During the first iteration, the original image is applied at level j input image. This will produce the level j-1 approximation and level j prediction. For the next iteration, the previous level j-1 approximation output is used as an input to produce next approximation. Here each process is composed of 3 steps. First step is to compute a reduced resolution approximation of input image, which is nothing but a downsample in this figure. Downsampling is done by filtering input and downsampling the filtered result by factor of 2. Here the variety of filtering operations can be used for downsampling, like neighborhood averaging, which produces the Gaussian pyramid, or we can use no filter that will result in sampling pyramid. The second step is upsample the output of previous step by factor of 2 and then filter the result. This creates the prediction image. As you can see in this block diagram, it will produce prediction image with the same resolution as the input by interpolating the intensities between the pixels of the previous step. This interpolation is done using interpolation filter as shown in this block diagram. The third step is to compute the difference between the prediction of step 2 and the input of step 1. This difference will produce level j prediction residual output that can be later used to reconstruct the original image. A prediction residual pyramid can be used to generate the corresponding approximation pyramid, including the original image without any error. So executing these steps for p times produces 2 intermediate results related to p plus 1 level and prediction residual pyramid. The level j-1 approximation output are used to produce the approximation pyramid. This is about wavelets in digital image processing. Hope you have understood the topic. Thank you.